Hello and welcome. In this lesson we'll be covering a couple different things. One, factoring polynomials completely, and two, solving equations, quadratic equations, by factoring. So first we'll take a look at this exploration page, and I'm just going to go over some of these really briefly and quickly so you get an idea of what we're going to be looking at here. So if I look at this first one, x cubed plus x squared, I can rewrite x cubed, x cubed plus x squared. And x cubed is x times x times x. And x squared is x times x. And so they both have two x's in them. So I can factor this out. The x times x is x squared. When I factor it out of this side, I get 1x left. And you might be tempted to just leave it because over here the x, you're taking out the two x's, but you have to remember in multiplication I'm leaving something behind. So I'm leaving 1 behind, and so this would be 1. And so x squared times x plus 1 would be this thing factored completely. I cannot factor it any further than that. There is a kind of factoring called difference of squares. And if you can write something as a difference of squares, if I look at this second one, x cubed minus x, I can see that they both have an x. And so this would be, I take out the x, and I'm left with x squared minus 1. And if I can write this as a difference, remember the difference is just subtract. So I have to write them as squares. So the x squared is given, it's already x squared. But 1 is also a square. That's the same as 1 squared. And so when you have a difference of squares, that factors really nicely to x times x plus 1 and x minus 1. So you just put the same variables, x and 1, but with one with a plus and one with a minus. And that's whenever you can write something as a difference of squares. And we'll see another example of that here in a moment. So let's look down here at g, x cubed minus 4x. Once again, I see they both have an x. So I take out the x, and I'm left with, if I take out one of the three x's, I'm left with two more, so x squared minus 4. And 4 is 2 squared. So there's the difference of squares. X squared minus 2 squared. And so I can write this as x, which is this x here, times, and then I put x and 2 and x and 2, and I put a plus and a minus. And that's it. Okay, I'm going to let you practice with some of these on your own. We're going to move into the next page of notes. All right. So factoring by grouping is a specific way of factoring, but I'm actually going to do this with we've talked about factoring with boxes before. We're going to use the box in there too. So we put the box up. We have 4 different terms. The key is to write the terms that have factors in common next to each other. So I'm going to put x cubed in this box. I'm going to put 3x squared in the next box, 2x down here. So if I look at this box, this column, they both have an x in common. If I look at this row, they both have x's in common too, 2 x's. And then I'm going to put 6 down in the bottom right. And they have a 3 in common with that column, and the 2 in common with that row. And then you just factor by greatest common factor like we've seen before. So here I take out x squared, and when I take out the x squared, that leaves an x here. And then I say x squared times what would give me 3x squared, and that would be 3. And then I ask myself 3 times what would give me 6, and that would be 2. And just to check, 2 times x is 2x, x squared times x is x cubed, x squared times 3 is 3x squared, and then 3 times 2 is 6. And so our factors are x plus 3 times x squared plus 2. And in this next example, I've got x squared plus y plus xy. With this one, I'm going to have to rearrange them. The other one, it fit in pretty nicely. We just follow the order. But here, we're going to have to move things around a little bit so that we have things in common next to each other. So I'm going to start with x squared in the upper left. And then instead of putting y in the next box here, I'm going to put x there. And then I'm going to put xy opposite that, because it has an x in common with the x squared. And then the final thing I'm going to put is y down here. And so I look at x squared and x, they have an x in common. And x times x is x squared. X times 1 is x. And x times y is xy. And then just to be sure, y times 1 is y. And so the factors of this particular thing that we do by grouping with the box is x plus 1 times x plus y. And that's the final answer here for these two examples. So I invite you to pause the video and see if you can factor out number 1 and number 2. I'm going to pause and work these problems through, and then you unpause the video and you can compare your answers with what I got. So there are my answers. Please compare them. If you have any questions, please reach out to me. Send me an email. Send me a message through Canvas. Write it down so that we can talk about it during our Zoom meetings. Something like that. Let's move on to the next problem here. When it means to factor completely, it means putting together all of the factoring strategies that we've used up to this point. And so if we look at example 2, this first example here, we've got x cubed plus 6x squared minus 18x. And the first thing I want to check for is greatest common factor. And so I look at these and they all have an x. And so I can take out, the first thing I can do is take out an x. And that leaves x times x squared plus 6x minus 18. I just took out the x. If I were to multiply x back again, that would give me the original. That's just a check sort of mentally to see, did I factor out that GCF, that greatest common factor, correctly. And then I take x squared plus 6x minus 18. And I want to factor that down. And so I look at my AC value, which is 1 times negative 18, which is negative 18. And I take my B value, which is 6. And I'm looking for numbers that multiply to give me negative 18 that combine to give me 6. And since 18 is negative, that means one of the factors must be negative, and one of the factors must be positive. So I take 1 times 18 just to start, and I look at 6. Since it's positive, 18 must be positive in order for that to be a positive result. So negative 1 times 18 would be negative 18, and negative 1 plus 18 would be 17, and that's not it. So I'm going to look at negative 2 times 9. Negative 2 times 9 is negative 18. Negative 2 plus 9 would be would just be 7. And, well, that's closer to 6. It's not 6, so we're still going to look. So I say negative 3. Negative 3 times 6 is negative 18. And negative 3 plus 6 is 3. And that's not it either. So I asked myself, will 4 go into 18? It will not. Neither will 5. And when we get to 6, then we're just switching sides, 6 and 3. So these are all of the factors that we can list. Since none of them work, we can say that this trinomial, x squared plus 6x minus 18, cannot be factored any further. And so this would be our final answer. We would just leave the answer like that because we can't factor x squared plus 6x minus 18 any further. And without writing out all of these factors like we did, we couldn't determine that this could not be factored further without doing that. Let's look at the other example. So once again, I'm going to check for greatest common factor. X to the fourth minus 28x squared. They both have two x's that I can take out. And so I take out x squared times x squared. X times x squared times x squared is x to the fourth minus 28. And so I look at this, and there's two terms here. I might be able to say, well, what would the middle term be if this were a quadratic ax squared plus bx plus c? And there's no middle term that I can see, so I might write it as x squared plus 0x minus 28 and say my AC value would be negative 28 and my B value would be 0. And since 28 is negative, one must be positive, the other must be negative. Since I look at 0, it doesn't really matter which one I put the negative on. So I say 1 times negative 28, and that'd give me negative 27. That's not 0. 2 times negative 14. That'd be negative 12. That's not 0. 3 won't go into 28. 4 will. 4 times negative 7. And that would be negative 3. And that's not 0. So we're looking at the same sort of situation as we saw before in that other example. This is as far as we can take this, x squared minus 28. If you looked at it as a difference of squares, 28 would need to be a perfect square, like, for example, 25, because 25 is 5 squared. But since 28 is not a perfect square, such as 5 squared or 6 squared or that sort of thing, then we can conclude this is not a difference of squares. We can't factor it that way either. So that means this is factored completely. All right, we're going to move down. So to solve things by factoring, 1, you factor the polynomial completely. Make sure that your equation is in standard form and is on one side of the equal sign. That's number 1. Number 2, take each factor that contains a variable and set it equal to 0. That's step 2. And I'm going to go through an example to show you what this looks like here in just a moment. Step 3, solve for each variable. Step 4, the degree of your polynomial should be the same as the number of answers you get. So solving an equation by factoring completely. Looking at number 4 first, as I looked at this equation, 2x cubed is degree 3. That means I'm going to look for 3 different solutions to this when I'm finished. So our first step would be to bring everything to one side. So that'd be 2x cubed. If I subtract 10x from both sides, that's going to leave this as 0 and bring negative 10x over. So I'm going to have 2x cubed plus 8x squared minus 10x is equal to 0 because we subtracted 10x from the left-hand side, the right-hand side. So now we want to factor this completely. So the first thing I do is I look at this and it has an x that I can take out. So I take out the x, and then I'm left with 2. I can also take out a 2 because 2, 8, and 10 are all even. So I can take a 2x out, and then I'm left with x squared plus 4x minus 5. With each of these terms, I'm thinking, what do I take out? 2x times x squared is 2x cubed. 2x times 4x is 8x squared. And 2x times negative 5 would be negative 10x. And so I'm going to set that equal to 0 still. And then I look inside, x squared plus 4x minus 5. And here I'm going to take and see my AC value would be negative 5. And my B value would be 4. And so I'm looking for two numbers that multiply to give me negative 5 and combine to give me 4. And 5 is prime, so it's 1 times 5. I just have to decide where the negative is. Since B is 4 and it's positive, I need to put the negative on the smaller absolute value. Negative 1 times 5 is negative 5, and negative 1 plus 5 would be 4. So those are the numbers that we're looking for. So then I say this inside part is x minus 1 and x plus 5. And then I've got the 2x on the outside over here as well. And this is equal to 0. So my next step here is to take 2x and set it equal to 0. So 2x is equal to 0. Divide both sides by 2. And x is equal to 0 divided by 2 is still 0. So x equals 0 is one of my solutions. The next thing I want to do is take x minus 1 and do the same thing. Set it equal to 0. So x minus 1 is equal to 0. Add 1 to both sides. And x is equal to 0 plus 1 is 1. X plus 5, I'm going to take that factor and set it equal to 0. X plus 5 equals 0. I'll subtract 5 from both sides. And x equals negative 5. And so that is another solution here. So I have three solutions. X equals 0, x equals 1, and x equals negative 5. And all of them will work in this original equation. So I want you to go through and try each of these on your own. 3x cubed minus 12x, number 3, number 4, number 5. Each of these. Try each of these on your own. Stop the video. And then when you unpause the video, you can compare your answers with what I have. And then you can go from there. So here are my answers. Compare them to see that you got the same answers. If you have any questions about how those answers, how I arrived at those answers, again, write them down. Please contact me and we can go through those together. Now it's your turn to practice. Go to the Big Ideas assignment and complete the assignment. Thank you. Bye.